Hi guys, this is Mrs. Mendy, and I'm going to talk to you today about molar mass. Because we talked about moles before, but now we're going to talk about molar mass. Now remember when you're looking at the periodic table that atomic mass is this big messy number on the periodic table, and it depends on your periodic table how many decimal places this goes to. But this number down here, and it will always have some kind of decimal places usually, is the atomic mass of whatever element is in that little rectangle with it. So here it's sodium, and it's in AMUs, or atomic mass units. And that's basically how many hydrogens does it weigh? About. But it is also the number of grams in 1 mole of sodium atoms. So that's convenient, right? So if we just have a mole of sodium atoms, this is how many grams it is. Okay, soak that in. So molar mass then is defined as how many grams are in 1 mole of whatever particle that is. Okay, the molar mass of sodium is about 23 grams. Okay, so that means that 6.022 times 10 to the 23rd sodium atoms, remember that's how many are in a mole, is right this number here, that many sodium atoms weighs 23 grams. Okay, easy peasy, it's right there on the periodic table. Remember that a mole is 6.022 times 10 to the 23rd of anything. And here's Avogadro again, this lovely, handsome picture of him. Remember that scientists picked that number on purpose so that the AMUs, the atomic mass units, would be equal to the number of grams in a mole. That's how they picked how many was in a mole, okay? So that it would be very convenient. Okay, so saying this again, just to kind of help this sink in, a mole of water molecules is about 18 grams. So here's, if this is 1 water molecule, and 1 water molecule weighs about 18 AMUs, atomic mass units. So if we had 6.02 times 10 to the 23rd of this molecule, that would be about 18 grams of water. Okay? So this we can deal with. Remember, this is why we needed moles in the first place, is so that we could kind of think about how many molecules we had, but in a size that we could deal with as human beings. Okay, so double check that you got what I just said. How many grams are in a mole of gold? So AU. Well, look, there it is right there. It's 196.97. How many grams in a mole of oxygen? It's 15.99, or that usually rounds up to 16.01, depends. Or to 00. Tin, SN, it's has 118.71 grams in a mole. Okay? So it's straightforward once you know what it is. But what if you want to know how many grams are in a mole of molecules, not just atoms, so not just a single atom, so it's not going to be written on the periodic table? Here is how. You add up the atomic masses of all the atoms in that molecule. Okay? Example. Sodium chloride, or just regular table salt. So it's NaCl. So if we look on our periodic table, we can see that sodium's atomic mass is 22.98 and chlorine's is 35.45 about. Okay, so we add those two together because you've got one of these and one of these. So one of these weighs this much, one of the chlorines weighs this much. Okay, that's how many grams in a mole of these. So if we add them together, if we have a mole of this whole molecule, we just add up a mole of this plus a mole of this equals a mole of this. All right, so when you add that up, and it's about 58.44 grams. Okay, not so bad. But you do have to remember how to read chemical formulas. Otherwise, you will not be able to do. This is a simple one. Okay, but for bigger molecules, you will have to know what this means. You'll have to know how many of each of these kinds of atoms you have. So you'll have to multiply the molar mass by the number of atoms in the molecule. So this is the chemical formula for glucose. It's kind of sugar that's in all life on Earth. Okay, so if we're figuring out how much a mole of sugar weighs, this kind of sugar, there's a zillion types of sugar, but this particular one, glucose. So we're going to look up carbon and hydrogen and oxygen in your periodic table because you got to know how much one molecule or one atom of carbon weighs so that you can figure out how many in this. Okay, so we're going to say, look, this molecule has 6 atoms of carbon in it because this little 6 goes with this C. And so then we know that from our periodic table that each one of those is 12.011. I'm rounding it to 12 grams up here. 12 grams in a mole of 1 mole. But if there's 6 atoms in there, so then we're going to multiply these together. That's a hint of what's coming next. Okay, then if for the hydrogen, if there are 12 atoms of hydrogen, then we're going to multiply it by its atomic mass here. Okay, and then for the oxygen, you're going to do the same thing. There's 6 atoms in 1 molecule of glucose, so we're going to multiply the mass of 1 mole of oxygen times 6. Okay? You're just saying 6 of these weighs this much, and 12 of these, and they each weigh this much, and 12 of these. So it's 6 times 12 plus 12 times 1 plus 6 times 16, and that equals 180 grams. So 1 mole of glucose molecules has a mass of about 180 grams. Okay? That's it for today. Oh, and you're going to practice later.